So we just uploaded a virtual training here. It was originally going to be an in-person training at EmberConf, but because the conference was canceled, we went ahead and made it a video, and now we can share it with everyone. And even though it was going to be delivered to Ember developers, there's really very little having to do with Ember specifically. So I think there's a lot of value in here for anyone building JavaScript apps with Ember or React or anything else. So I hope you enjoy and learn a little bit about domain modeling with Mirage JS. Hey everybody, welcome to the domain modeling training here for EmberConf 2020 or CoronaConf 2020. Sorry we couldn't see you in person this year. We were really looking forward to it as we do every year, but I think we have a good training here for you. And yeah, so let's get right into it. So you can find the training here on our EmberMap GitHub at EmberConf 2020, and I'll have a link to this, right in the email. And this is the repository with the demo for our training. And so this is an Ember app. So the first step would be to go ahead and clone this, go ahead and yarn install. And then once you have that running, you should just be able to run yarn start and kind of kick everything off. So while we're doing that, I'll just explain kind of how this is going to go. The README here is kind of the overview of our training. And that's also in the repository, of course, so you can just pop that open if you want to follow along here. So let's see how this is doing. Once this gets going, we should be able to visit localhost 4200. And if your screen looks like this, that means everything is working. So I'm just going to go ahead and make this full screen just so we have a little bit more room to work with here. And let's take a look at this overview. So domain modeling, what are we really talking about here? Well, the reason domain modeling is important is because, traditionally with server-side rendered apps, like let's say Wikipedia, it's just talking to a server. When the user makes a request for a web page, the server lives right next to the database. And in most web apps, the database is the source of truth. Now, depending on your background, you might have some experience working with databases and servers, or you might just be focused more on the front end and only interact with server data over an API, but you've maybe never done it, dealt with it yourself. So in most web apps, the database is the source of truth. And with traditional server-side rendering, frameworks like Rails and Laravel have this luxury where they get to talk directly to the database as soon as they're rendering a page. And so a lot of the issues that we have when building rich JavaScript apps like Ember apps don't really come up because, as soon as I go to a Wikipedia article, the backend server is going to request the latest version of that article from the database, render it to an HTML page, and then send it up to me. That's a simple model, and it makes it really easy to get started, right? But it's also limiting in the sense that when the user gets that page from Wikipedia, that page could just be sitting there. And if there was an edit made and the backend, let's say the source of truth, the database were to update, well, the user is just looking at a stale page, right? And so in order to get fresh data, the user would have to Command R, would have to refresh the page and get a re-rendered from the server. So it's simple, right? There's trade-offs and everything. It's a simple model, but it really puts the burden of getting fresh data on the user. Whereas, with something like an application like Slack that is giving you real-time messages as they change, that model wouldn't really be possible. It wouldn't really be possible to require the user to have to go back to the server on their own initiative each time they wanted to see fresh data. And that's exactly why we build JavaScript apps, because it enables this richer experience where we can do a lot more on the user's behalf. But again, this comes with trade-offs as well, because now we have to be intelligent about how to get data from our source of truth, our database and our server, to all of our clients. And now that our clients are kind of disconnected from our backend systems, each client that is running our Ember app is working with its own local set of data, and it is now disconnected. And so that's really the motivation of this entire question of domain modeling, because we now have to answer this question: what's the best, most efficient way to get data from our source of truth, our database, to each of our clients when they need it? sometimes it makes sense to render from cache on the client. You already have the data you need, but sometimes you want to push new data as soon as it comes up, just like in Slack. So that's really the motivation behind domain modeling. It's how best to organize and structure our data so that it can be efficiently sent to our clients. So let's take a look at this demo app here. And if everything's running again, you should see something that looks like this. We're going to go through all these exercises over here. So you can always pop this out and jump around, or you can just use this to change as we go along. But let's take a look at this exercise 1 here. So this is a Mirage Inspector, and we're going to be learning about domain modeling with Mirage, because Mirage is really kind of focused on making the server as simple as possible for the needs of the front-end developer, right? There's a lot of complexities that come with writing a real production server and a database server, which power most web applications. And things like adding indexes to make sure your database queries are fast. And that's kind of a back-end concern. And those things are important, but they're not as important for the day-to-day life of a front-end developer. Really, Mirage is about abstracting away as much of those details as possible while still exposing the concepts needed and the primitives needed for us to get a high fidelity experience as front-end developers working against the Mirage server. So that's why we're going to use Mirage to learn about domain modeling here. And so if you've only ever used Mirage with Ember, you might be used to using Ember CLI Mirage, but under the hood, Mirage JS is the library that powers that, and it works in any framework. So we're just going to see all these examples using Mirage JS directly. So this is kind of an example of the simplest Mirage server that you could configure. It just has this routes hook, and it has one API endpoint here. So our server is kind of running on all these pages. It just uses the config from the current page here. So our server is running, and then here we have on the right side our kind of mock client. So you can think of this as your Ember app, the JavaScript that's going to be making the network request to your backend. And so we can make a request here. We can see we have a get request to find a /movies. So we can type in /movies and see that it returns the JSON here. So it's just returning exactly what we defined here in our route. And we can also see what headers we have and the status code right here. And if we were to try to make a request to an unhandled endpoint, we'll see that. So we have some error handling and all that kind of stuff, but this is basically just simulating this. And because this is exercise 1, we can come back over to our app here. And where all these exercises are located is in app exercises. So we can pop open exercise 1 just like this. And if we wanted to change this, which we'll be doing throughout the training, we could add, change this and let's say dark night, year 2008, save that. And if we come back, this will reload. And now when we try to get movies, we'll see all the data here. So this is kind of how we're going to use this inspector training app. Now you'll notice that we have a database tab here, and that's because Mirage has, a simulated database, but it says the database is empty. And that's because we haven't defined any models for our Mirage server. So let's flip over to exercise 2 and take a look here. This exercise is just about looking at how to implement kind of a basic Crud server with Mirage. So here we can see we have many more routes defined. And we have this new serializers option. But if we look at the database, we see that it's still empty. And the way we can create database tables in Mirage is to define models. So let's come back to our code and we'll open up exercise 2. And you can follow along here. So at the top of exercise 2, where we import these from Mirage, we'll go ahead and import model as well. And then we'll create a new option for our server definition called models. And we can see that these routes here all interact with user. So that's the model that we want to create. So if we define a key here called user and we just say that's a model and save that, now when we come back to our page, we'll see that the database tab says the users table has no record. So just with adding this, we've basically told Mirage to expect there to be this kind of user resource in our server. Okay, so we have a users table, but we have no records. How do we create some records? Well, back in our code, we can also use a new top level hook called seeds. And this is a hook that takes in a server and lets us create data. So we can create a user by calling server.create user, just like that. If we save that and come back, now in our database, we see we have a record. This is a pretty boring record. It just has an ID of 1. So let's give it a little bit more data. And with Mirage, you can just kind of define attributes like this on the fly. So we'll say name is Sam. And let's create another one, name of Ryan. So now our users table has 2 records. And the IDs are being auto-generated by Mirage. Again, this is how most backend systems actually work. The ID, this is actually kind of an important concept for this course because ID is an identifier. It's a unique identifier. This is the globally unique representation of this object in our system. And right now, it exists as a record in our database, but Mirage is just going to give that to us automatically. Okay, so now that we have data in our users table here, we can come back and take a look at some of these routes. And these are the kind of 5 standard RESTful routes in a REST backend. So let's look at this one first. We have a get to /users and it returns schema.users.all. So if we type in users here and hit enter, there we see Sam and Ryan. So this is how you interact with the state of Mirage's database. We can also just get a single one. Let's go ahead and grab Ryan at ID 2. We can create a new user. So if we go to post/users, well, this expects a certain format. In this case, it's going to look a lot like our kind of payload down here when we send a GET request. So we can go ahead and say name is Yehuda. And I'm just going to go ahead and zoom out a little bit, give us some more room. And now if I send over this request, we'll see that this was a 201 created, and the response told us the name was Yehuda and the ID was 3. So even though we didn't specify an ID here, if we take a look at our database, we see that this route handler right here went ahead and created the new record into our database. Mirage assigned it an ID of 3 and we got it back here. And so, we can create records just like this, just like you would expect. And we can patch records as well. So we can update Sam, let's say, to Samwise. And if I go ahead and send this out, then we'll see that that updates in the database as well. And of course, we can delete users too. So say bye-bye to Sam. So that's kind of the basics of a model and how it creates the data here in the database, and how these kind of 5, you might hear them called RESTful or resourceful routes exist. And again, if you were to look at a Rails or a Laravel kind of starting guide, you would see something very similar here, how to perform what we call basic CRUD operations on a resource. So the way to think about this is that we have this database table in our backend and it has this data. And the question is, how do we expose this data to be read and manipulated by clients? And this is the conventional way to do REST. And it takes advantage of these verbs here and also this resource. And because this is so conventional, Mirage actually has a shorthand. So instead of having to learn how to write all these, we can actually go ahead and delete these and say this.resource user. So this is basically kind of a way to say we're exposing a user resource from our server to our clients. And so if we come back, we see that that's really simplified this config here. We still have this data, but if we were to go ahead and get the users, then we see we have the same result. And we can do all the other same things as well. So we could send a delete request and say bye to Ryan, and there we go. And now when we get all the users, we just get Sam. So, and I'll just refresh this to get Ryan back. So this is pretty cool. And, again, the purpose of this course is to kind of get you familiar with how ultimately this data is stored in the backend. So we can see that this is the source of truth. And when our client app sends a request to users, we're kind of getting this snapshot of the database at a point in time. And so just like in the server rendered app case, our client app can now use this and render on the client, the users in the system. Now, in this case, we see basically everything in the database. So this is, you can think of as like the easiest case you'll ever encounter, because our client is able to get basically a copy of the database in a certain format. In real world situations, the database usually has way more records than can just be sent to the client. And so that's where some of the tricks come. But this is kind of the simplest case. So let's go ahead and go to exercise 3. And you're just going to practice creating a model on your own and kind of practice creating some data and exploring the inspector. So if you come back to the instructions here, you'll see that exercise 3 says, let's create another model called a message. And this is going to be, throughout this training, we're going to look at something that looks kind of like a Slack or a Discord app. So there'll be users, there'll be messages, things like that. And so here, a message just looks like this, pretty simple, just one kind of column, one attribute called text with the text of the message. So define a message model and create some messages and seeds, add a resource to routes for the message resource, and then explore the database tab and making requests. So again, back in your demo app here, you should be on exercise 3. And over in your code, you can just pop open exercise 3 exercise and make changes to this. And you'll see those changes right here and it will update this. And then once you are kind of comfortable, you can just peek at the solution and see where we ended up. But go ahead and pause the video now and just play around with this for a little bit. All right, welcome back. So let's go ahead and do this. So if we want to make another model, we can just come here and make a message model. Let's go ahead and create Sam and Ryan. And let's also create a message. So we'll create a message with text attribute. Hey, what's up? Oh, Corona. And we can come down here and expose the message resource as well. So with that change, we can come back and check out exercise 3. And now if we look at our database, we've got 2 tables. So we have users and we have messages here. And we can perform all these kind of requests to our messages just like we can to our users. So we can get all of our messages, we can get a single message, we can delete a message, and we can see that everything is working. Okay, so again, this is very similar to how this would work on the back end, having 2 separate tables for these 2 conceptual resources in our system. Now, let's go ahead and go to exercise 4 and talk about associations. So maybe if you thought ahead, the natural question that you might already have is, let's say that we were actually building an app like Slack, and from our client app's perspective, we need to render all the messages in the general channel. And so we need to fetch all that data, and we need to fetch it in a way that's going to make our lives easy, right? Well, if we look at the data that's being stored here in the database, we have these 2 users and we have these messages, but right now they're not associated with each other. These messages are just kind of by themselves. We don't actually know who wrote each message. And so our database is incomplete in a sense. The source of truth is kind of inaccurate because it doesn't really make sense for a message to exist without a reference of some sort to a user. And this is kind of one of the first points of domain modeling. Domain modeling is really, again, how to organize this data. There's a million ways we could organize this data. We're learning to do it in kind of the most standard and conventional way because there are so many problems that you encounter based on how you decide to store and share your data that these conventions and standards have evolved over time and given us these really rock solid principles for how to do it. So there's a million ways we could choose to associate a message with a user, but the way we're going to do it is by using a foreign key. So what does that look like? Well, let's take a look here at users. Users 2 is Ryan, right? So the user with the identifier of 2 is Ryan. So there's never going to be another user in this system with an ID of 2. So let's say this first message was written by Ryan. How might we store this? Well, using a foreign key would look something like this, user ID 2. Let's save that. And now over in messages, whoops, I think we're on exercise 4 and I think I was still on 3. So over in 4 here, we'll say user ID is 2. And now if we take a look, we see we have a new kind of column in our database, and this record has a user ID too. So this is really a reference as a pointer to Ryan. And so we could go here and say this has user ID 2, this has user ID 1, user ID 2, and user ID 1. So this is kind of a conversation between Sam and Ryan, right? And now our database looks like this. And now if we were in our Ember code and we needed to fetch the data to render the whole conversation, how might we do that? Well, we could get all the messages. And if we send a get to all the messages, there we've got 4 of them. And the messages have the text that we need to render, and they also point to the user ID, but we probably want to show who the name of the person is, so we also need the users. And so we can go ahead and fetch the users, and now between these 2 requests, we have everything we need, right? Because we know user 1 is Sam, and we know user 2 is Ryan. So on the front end, if we made both of these requests, we could stitch these 2 together and then render in our templates the conversation, right? And so this is typically how this data is stored. Now, this notion of a foreign key is, again, it's just a fancy word for something that points to a unique record elsewhere in the system. Is so common that it's actually built into Mirage. And so the way we can take advantage of this convention is by using a belongs to relationship. So what we're going to do is import belongs to from Mirage JS. And what we can do is come down to our message model, which is the model that owns the foreign key here. And we can call .extend, and we can say that it has a user reference, which is a belongs to relationship. Belongs to means that this user property points to a single model of the other type. So let me just comment that out really quick, and let's get rid of these first. And go back to just having messages with text. So you can see how this changes the database. So I've saved this, and back in the database, we're just back to kind of these unassociated records, right? Messages just have a text field and an ID. And now if we add this relationship to our message and save it, if we come back to messages, we'll know that Mirage has went ahead and added a user ID column for us without us even having to write user ID anywhere. And again, that's because that's exactly what this helper is doing. It's establishing this convention of saying, you know what, messages now have a relationship to a user, and so they need a foreign key to store that information. And so what's cool about this is that, well, we could still do something like, user ID is 2 here, but 2, we just have to know that that's Ryan. Instead, what we can do is say, let's get the user model from Mirage, and we'll pass that in as the user for the message here. And this attribute here matches this one right here. So if we save that and come back and take a look at that. User ID is 2, which is pointing to Ryan. And so we can do the same thing like this. This user is Sam, this user is Ryan, and this user is Sam. And so if we look at the data, we would expect to see the user IDs just like before, and we do. So this kind of belongs to abstraction is really just, a light layer around what is ultimately these foreign keys in a database. So again, if you've never worked with this before, this is the magic under the hood. When you make a request and get this big graph of data in your Ember app, maybe that you're used to working on day to day, at the end of the day, all this data is being stored in separate database tables that look just like this. Another term you might hear when you start diving into kind of server-side code or concepts is an ORM, which stands for an Object Relational Mapper, which is exactly what we're doing right here. We're basically defining our schema, our domain model for our resources, and by wiring up these relationships, we are mapping data to different objects. And that's why we can basically work with these objects like this. This is a user object, a model. This is a message model. And that's exactly what an ORM does. It's just like Ember Data. If you're used to working with that on the front end, it wraps the underlying records from the database or the data store around objects that lets you work with them in a relationship-aware way. So this is pretty cool, and we have our data set up in our database. We can still get our users. we can still get our messages, and our client could basically stitch these together to get the data it needs to render the channel page. But the relationship actually does a little bit more for us as well. So again, we have these two resources exposed from our routes here. So check this out. We have Sam and Ryan, and they each have two messages, right? What if I were to send a delete request to user/2, which is Ryan? Well, look at that. 2 of 4, the record was deleted. So if we go back to users, there's only Sam. But notice that the user ID field was updated in the messages table for Ryan's 2 messages. So this is something else that Mirage and again other backend systems are usually capable of doing, is basically keeping these foreign keys in sync and ensuring that there is consistency in our database. Now in a real backend system, you might have even more control, or you want to add more constraints and say, you know what, a message should never exist in our database without a pointer to a user, because that's basically just not valid. So you might hear this called as an orphan record in our database. And a lot of systems have support for cascading deletes. Basically, if I were to delete Ryan, the user, make sure we also delete all of his associated messages in our backend system. But basically, you can see here that Mirage is doing some work for us to keep these foreign keys in sync, which is why you want to lean on these conventions of relationships and foreign keys. Again, this is all coming back to this notion of domain modeling and how we can just stand on the shoulders of all the precedents that we have, so we're not reinventing the wheel with how to keep these things in sync and how to expose relationships over the network. It's really easy to fall into that trap because we write backends for every app that we write, and we can choose to do it however we want. And so the real value here is learning in these conventions and kind of learning how to stay within these lines. Okay, so that was exercise 4. If we go over to 5, and this is going to be a practice exercise where you get to practice making a belongs to relationship. If you come over here to the README and look at exercise 5, let's say that users can also have activities. And an activity can be like a mention or a reaction or an upload. And so this is going to be a new model in our system. And so what you're going to do is create a new activity model, associate it with a user, and go ahead and create some activities for a user. And again, this is kind of the structure of an activity. It has a kind property, and then it also has a foreign key to a user. So go ahead and pause the video and play around with that for a little bit. All right, time to compare our work. So let's come over here to exercise 5. And basically we want to create a new activity model. It's going to look like this. And we also want it to belong to a user. So we'll write belongs to here. And we can come down and server.create an activity. And let's say this is for user Sam, and it is a mention. Let's take a look at our database here. We see activities, mention, and that one points to Sam. And we could also come down here and expose the activity resource from our server. And you can imagine doing this so that, again, if we were building something like a page to show all of our latest activities, now our client has the ability to query that. And again, if we were to look at this, let's go ahead and delete user/1, and we see the user ID is cleared from the activity as well as these messages. So just another little example of this belongs to relationship, which is really kind of fundamental to this whole thing. So let's go on to exercise 6 here. So the other main relationship type is a has many relationship. And you might see this word association relationship. If you see this kind of in any of these areas, Mirage, Rails, Laravel, Ember Data, it's the same thing. It's just a synonym for each other. And so in exercise 6, we are kind of back to just having these two models, a user and a message. So we've removed the belongs to from the message side, and we just have this data that's kind of unassociated with each other. So the other way we could choose to store this is by adding the relationship to the user side. So instead of extending the message, let's extend the user, and we'll import has many from Mirage JS, and we'll say a user has many messages. So we'll give it a messages property, and we'll say has many. Let's come back and see how that changed the database. Now we see that Mirage has added a message IDs column to each one of our users. So the has many side is going to give us an array of foreign keys, whereas the belongs to is just going to give us a single foreign key, and that is reflected in the name. And so now we can associate users and messages again, but we can do it in this way. Basically now these users have a messages property that can take in messages. So if we were to assign some variables here, let's let Sam and Ryan equal the users. And then for these, let's let them just be these local variables, message 1, message 2, message 3, and message 4. And we can pass these into these create statements, but we can also use other APIs from Mirage, like update, which lets us update attributes. So we can say, let's update Sam's messages to be an array of messages, and he'll have message 2 and message 4. And Ryan will have message 1 and message 3. So if we save that, we can see we're still able to work with these models, but under the hood, Mirage is keeping these IDs in sync for us. But now we do have this relationship encoded. The messages kind of are on their own. But if we wanted to query for all the messages, we can go ahead and get our users, and we can see from our client, Sam has messages 2 and 4. And that way, again, if I were to query the messages, I could stitch these together and say, okay, these are Sam's 2 messages, right? And we also have some behavior here where in the same way, we can keep the foreign keys in sync through these encoded relationships. So Sam has messages 2 and 4 over here. And so if we were to send a delete request to messages 2, we see the message ID is updated here and it's removed from the table. So in the same way that the belongs to relationship works, the has many also keeps things in sync and is just another way to encode these relationships. Now, one thing I do want to point out is if you do have experience writing servers or storing data in databases, this might look a little strange to you because most database systems and backend server systems don't actually support arrays of foreign keys like this. They will have a notion of has many and belongs to, but under the hood at the database level, foreign keys will always just be individual keys. And there's a reason for that, but Mirage supports this because Mirage is kind of an abstraction around this, and there's actually situations where even if the database is only ever storing foreign keys, your server will expose server resources with an array like this, just like we saw here. So if we get all of the users, let's send a GET request to users, these come over as an array. So Mirage is really more about representing how server resources are exposed, and the database is done in this way, the has many side of the relationship, just to keep it as simple as possible. It ends up working exactly the same. It's just a slight abstraction, and so if you are confused about that, you might find that most systems only ever support individual keys, even if they end up giving you the same exact thing. So this is just a little bit of a higher level way to think about it, and it makes it kind of easy, like if this is actually how our server behaves for whatever reason, like if in this case, messages would probably belong to a user because that makes sense. And we already said that it doesn't really make sense for a message to exist in our system without a key to a user. It just doesn't really make sense. But there's lots of models and situations where it does make sense to have a record exist that may or may not point to something. So in that case, you might want the relationship to be on the has many side, and this is the way your server would expose it. And so with Mirage, it's very easy to model that. We just go ahead and add the new relationship and put has many, and that's all there is to it. Mirage is going to keep these foreign keys in sync for us. Okay, so we have has many, we have belongs to. You might be asking, well, why not both, right? So let's go over to exercise 7 and talk about the one-to-many relationship. So far we've only seen relationships on one side of the model or the other of the relationship. And the other model is basically not even aware that it points to the other resource, right? It's just a one-way relationship. Well, often you want relationships that are bidirectional. So you want the relationship to be on both sides, or for both sides of the relationship to be aware of the other, and for those two things to stay in sync. So let's see what that would look like. If we come over to exercise 7 here, what we're going to do is import belongs to and has many. And we're just going to say that a user has many messages, and a message belongs to a user. So if we save that, come back, look at our database, we'll see our familiar message IDs column was added to our users, and our user ID was added to our messages. So now back in the code, down here in seeds, let's do what we did before. Let Sam equals, let Ryan equals. And now when we're creating a message, we can pass in a user because we've defined that as a relationship. So user is Ryan. Save that and come take a look. And now if we see Ryan has a message IDs column that has 1 in it, and the first message is associated with Ryan. So these two things are being kept in sync with each other, even though we're just passing in the user right here. So let's finish this. User Sam, user Ryan, and user Sam. And now these look just like they did before, even though we were only really modifying this side. So this is another example. This is a bidirectional relationship. Mirage is basically inferring that these two things should be kept in sync with each other. And so if we were to go ahead and say delete messages /1, now we come back here and this is updated as well. That key is updated. So this is kind of the simplest example of a bidirectional relationship. And again, we saw how these were being kept in sync. Now you can make these two associations not represent the same relationship by saying inverse is null. But in this case, we actually want this. So again, why are we actually doing this in the first place? Well, if we have this conversation going on, does it make sense that if this message is deleted, then it should be updated on this side? Well, yeah, Sam's messages have changed if one of his messages was deleted. So this is kind of where you start to think about domain modeling from the sense of what is true about the logic of your system, what is factually true about the domain of your system. And that's why it's called domain modeling, because there's really no right answer when it comes to a lot of these questions. It has to do with the logic of your specific application, and that can change over time, which has implications for how you model your domain. But when we're talking about domain modeling and these structures, the question of which relationship to use is largely driven by what is true about your system. So in this case, a bidirectional relationship, we can see exactly how Mirage is keeping these two things in sync, and conceptually they represent the same relationship. Okay, so over in exercise 8, we've talked about one-way belongs to relationships, one-way has many relationships, and now we have a bidirectional one-to-many relationship. And the question is, well, when do we want to use each one of these relationship types? When does it make sense for two sides of the relationship to be kept in sync, or there only to be one model that has a foreign key? And a lot of this, again, is driven by the facts and the logic of your domain, but it's also driven by your UI and your clients and how they need to access data from your systems. And so, with our current setup where we have this one-to-many relationship here, we have a user that has many messages, and a message with a belongs to pointing back to the user. We can see our data here, and we know that our clients have the power to go ahead and render all the messages, this conversation, in some UI, right? So if we fetch all the messages, there we see our hypothetical Ember app could see all this data, and it knows the user ID for each message, and it can go ahead and grab all the users, and it can stitch these together and render the UI, right? But this is kind of cumbersome, and if we always made our front-end developers do this, or we're doing this as a front-end developers, it might not be the funnest part of our job, right? We have to kind of stitch these two pieces together, and really we just want an easier way to make this request. What if the first request to messages comes back, but then for whatever reason the second request kind of times out? We put our UI in a weird state. Ideally, we'd want to be able to get all this data in one single request. And kind of the first way that server-side systems solved this problem was by using server-side includes. So we can do this in Mirage with our serializer layer. So over here in exercise 8, we see we have a serializer. So let's come back to our code, open up exercise 8. And right here, so far we've just been using a single serializer for our whole application. This is called the REST serializer. And the serializer layer in Mirage or in other backend systems really has to do with the format of the data. So the shape of this data, the fact that this is an array, messages is in the root here. There's all sorts of different formats, but we're just using this kind of standard one. And so what we can do is actually define model-specific serializers to alter the behavior of how those models are serialized before they're sent up to the client. So in our case, what do we want to do? Well, we kind of would like it when we fetch the messages, instead of just getting the user ID, if we could also get the user record in this payload. The way we can do that is by defining a message serializer. It'll be REST serializer, but we'll call .extend on it. And then we can define an include key here, which is an array of relationships to include from our server. And because our message model here has a user relationship, we can say, all right, go ahead and include the user. So now if we go back to our inspector and fetch all the messages, here we see, just like before, all the messages. But if we scroll down, we see a new key on our payload called users, and it has the users right there. So just in one request, we now have everything we need to render the conversation. So that's pretty cool. The client is able to fetch this whole graph of data in one request. And looking at this, it really looks a lot like our database, right? We kind of have these two root keys that represent our database table names. And we have all this data here. Now by default, the way we've configured this, what we're getting is called side-loaded data. And that just refers to the fact that the main resource we're requesting, the list of all messages, is here. And then the included resources are kind of side-loaded, literally just they're loaded alongside the main resource here in this JSON object. And this produces what's called normalized data. And so normalized data really is just a fancy way of saying data that has no duplicated values in it. So if we look at our database, we can see that, like we were saying kind of at the beginning, this ID field here, it represents identity. And what does identity mean? It means this is the globally single place where this resource exists, is defined. It's not duplicated anywhere else. So if I asked you, what's the name of the user 2? I can look right here and see it's Ryan. And it's not going to exist anywhere else in the system. And same with the text, same with all these records. And this is typically, again, how databases store data. They are normalized so that there's no duplication. You can think of, again, the database is really the root state of our entire web app, and everything kind of flares out from that. And so it's important when you're talking about the source of truth or the root state for anything, you have no duplication. And it's just like when we're writing Ember UI code, right? If you're writing computer properties or you're writing other pieces that derive from root state, you really want to identify what the smallest amount of root state is and derive everything else from that. Because when you duplicate data, you run the risk that the two duplicated pieces kind of fall out of sync, right? So interestingly enough, serializers actually have another option called embed. So if we were to set embed to true, let's take a look at how this affects our query. So we'll go ahead and send a GET request to messages. And now we have the messages key here, but if we scroll down, we don't see the user. And that's because the user has now become embedded within each message. And so instead of just user pointing to an ID, we actually embed the user like this. Now you may have worked with APIs like this before, because it's a pretty common way to make it a little bit easier for the front-end developer to just get what they need. And so you can imagine if we were rendering this conversation, now we don't have to do any work about stitching all this data together on the client. We can just loop over this array, and for each object here, render the text, and then render user.name, and we're basically good to go, right? Now, question for you, is this data normalized? Well, I see name of Ryan right here, and if I scroll down, I see a name of Ryan right here. So this payload is denormalized. Embedding often results in denormalized payloads. So again, there's kind of a trade-off here. On the one hand, if you're working in a client environment that doesn't have kind of the capabilities to stitch together all this data like Ember Data does, Ember Data expects normalized data so that it can create this graph of relationships on the client and let you traverse that graph. But other times, if you don't have an API like this, or you don't have a tool like Ember Data, this would be much simpler in some sense to just make this request, loop over these messages, and render directly to the screen. It's just that now you run the risk of editing this name and not having it reflect everywhere in your UI. So if you're rendering Ryan in all these places right here, and then you add some option to change the name, well, if you change it in one place, you have to make sure to change it everywhere, right? So this is like a fundamental question of when does it make sense to work with denormalized data and to kind of derive data from root state versus sending over the most highest fidelity version of the database data in the normalized way so that the client can understand where everything comes from. And different situations sometimes call for different answers to that question. Another kind of back-end term you might hear thrown around conversations like this is called a materialized view. And so really all of our responses have been materialized views of the database, but this one definitely is, again, because it is denormalized. It's really looking at our database state. It's a view of that state transformed in some way. You might hear that called a materialized view. Now, sometimes in back-end systems, the query needed to power a front end is so different from how it's stored ultimately in the database that back-end systems will materialize a view, a very specific view of the database data, and store that materialized view in another database table that is ready to be queried by the client. And so, again, this makes it way easier for the client. They can just fetch the data already in the format that they need for their particular page. But you can see as soon as you do this, you now have to deal with this notion of stale data and caching, because this materialized view is materialized from the root state. So if the root state changes, you need to make sure to regenerate that materialized view. Sounds a lot like what we do when we query data with Ember apps, right? So let's go on to exercise 9. And you're going to get a little bit of practice time with include and embed. So if we go back to the README here and we go down to exercise 9, let's say instead of rendering the conversation, we are in this hypothetical Slack app that we're building. We want to build a screen, for maybe the current user where I can click on my profile and I can just see all my messages. So I can just see all the messages that I've ever written. So how might we, expose our resources, and how might the user query that data? So go ahead and pause the video and give this a shot. Okay, let's compare our work. So we're over here in exercise 9. And thinking about it, kind of starting from the outside in, this is usually how I like to think about this. If we're in 9, what would I want to be able to do from the front end's perspective to get this data? So if we get all the users here, we see we have 2 users, Sam and Ryan. Let's say I'm on Sam's profile page, and now I want to go ahead and include all the messages? Well, we have the IDs right here. So if we just included the messages relationship for a user, we should be good to go. So we should just be able to copy this, define a serializer for the user, and go ahead and include the messages, right? And if we have an embed off and we get users/1, we'll go ahead and sideload those messages. And if we have embed on and we get users/1, then those will be embedded. So this looks pretty easy to work with, right? We could just render the user out and then list over each over user.messages, and boom, there we have all of our messages right here. Now this is an interesting question. We set embed to true here. Is this payload normalized data or denormalized data? Well, I don't see any duplication here, right? If we look at the database, we have the name in one spot and all these messages have text in one spot. So even though we used embed here, because messages is a has many relationship, there's actually no duplication going on here. So you'll just see that sometimes different situations kind of produce different results, but ultimately these are all kind of views or snapshots of the database as of a certain point in time. Now you might have noticed something interesting. Let's go ahead and turn embed off for the REST serializer for our user. And if we get users1 again, what do we see here? Well, we see that the messages are being sideloaded. The user Sam has messages 2 and 4. And if we take a look at 2 here, this is message 2 with the text, "Hey man." And the messages are also being serialized according to our message serializer, which we defined right here. And they're embedding their user. Now, most server-side frameworks and Mirage as well have ways to avoid this. Basically, to say whether or not a message, a serialized message, should include its user, if the request was for users1 or if the request was for messages. So you can add more logic to make the server more intelligent about when it should include or not include a related resource. But you can kind of already see here that this is a little difficult, right? Our server is having to do its best to make a guess about what the payload should be for the client. But really, the client knows best about what data it needs to render a particular page. If I'm rendering a list of users, I just want those users. I don't want their associated messages. If I'm rendering a conversation in a channel, I just want the messages and maybe include their users. But if I'm rendering, maybe I'm fetching these messages afterwards just for user 1, and I already have the user in my system, and so I don't need to include those either. So you have all these different pages that you're building in your UI, each with their own specific data requirements. This is one of the challenges with what we're calling server-side includes here, where the server decides whether to include related resources or not. And so what you've seen in recent years is the ability for clients to have more control to specify on their own from the querying side whether or not to include related resources. And that's what exercise 10 is all about. So let's go over to exercise 10. And we're looking at fetching a graph again, which is, when we say a graph, we're saying we're fetching a graph of data, which is nodes in a payload that point to each other, which is ultimately what our database is, right? And with our REST serializer and includes, that's what we were able to do, to send a single graph of data that the client could kind of stitch together or iterate over. So now we're talking about fetching a graph, but having it be driven from the client-side query. And if you have used JSON API, you kind of know where this is headed. So really the only difference here, we still have our one-to-many relationship, we have our data, but instead of using REST serializer, we're using JSON API serializer. And so if we look at our database here, we can see users have many messages. Let's go ahead and get our users. And again, if you've never seen JSON API before, it adds some more structure to our data. So you'll see a little bit more structure and ceremony here, but it's for good reason. So our user's response here is an array of these objects, and the objects always have a type and an ID, which kind of uniquely identify this resource. And then we have this attributes key, which tells us that there is a name of Sam. So we can grab Sam here at user/1. And what if we want to do that fetching where we fetch a graph? Well, we can go ahead and say, let's include the messages. And just like that, our JSON API backend has included the relationships here. And it tells us that your messages relationship has these two records. And if we scroll down, we'll see an included key. There they are. That's the full representation of that message resource. And notice we didn't have to change anything in our server. We are just using out of the box JSON API serializer. And the same thing works for messages. We can get a message and we can go ahead and include the user of that message. And this is all possible because JSON API is stricter in the sense of how it allows certain queries to come through and how it represents its data. So this is pretty amazing how far you can get with this. And a good question to ask here is whether this data is normalized or denormalized. And in the case of JSON API, it always produces normalized data. So you'll see here that this is the message of ID 1. So we have, again, this notion of identity right here. We have a pointer to our user, which has this identity right here, users:1, and then it's included right here. And let's go back to the situation where we saw the denormalized data, where we fetched the messages and then we include each message's user. Remember when we had embed off, each one of those was embedded within the message. And here we can see the only thing that each message gets is a pointer to a different user, right? So user2, user2, and user1. And then down here in included, we have the two users with their names. So you won't see name Sam show up twice anywhere in this payload. So this is completely normalized data, which again is really just a transformation of the database with enough information for our client to piece everything together. So that's kind of the difference between JSON API here, is that JSON API always produces normalized data. And that's because JSON API was really designed to get the data into a client-side identity map, into a client-side library like an Ember data that wants to know about all of the keys, the primary keys and the foreign keys, in order to stitch everything together and reform that graph of data on the client. So this works really well, especially when you have a tool like Ember Data or Orbit, something that expects a normalized payload to come over the wire. But ultimately, the higher level point here is putting more control in the client's hands, right? Giving the client the ability to query a backend and specify just what they need. And that keeps our server more flexible in general, right? We didn't have to change anything about these endpoints or about the serializer, and our client has all these different ways to query the backend for the specific needs of the particular UI that they're building. So does that sound familiar? Well, let's look at exercise 11. And exercise 11, a little typo here, is about fetching a graph with GraphQL. And so now that you kind of have an understanding of different ways to expose these server resources over the wire, you should have a better understanding of the motivation for GraphQL. And this really takes this idea to the logical conclusion, where it says we're actually going to have one single endpoint. If we scroll down and look at this, there's one single endpoint here, and it's completely generic, and we actually have a query language that the user can make in order to fetch the data in exactly the right way they need for their particular use case. So what does this look like? Well, you'll see in our server here, new server, we don't have the serializer anymore. And again, we just have the one route. But we still have our models and we still have our seeds. So again, this is our kind of domain modeling part of this. And this hasn't changed at all. This is like what's true about our system data. It's just how we're exposing it that's being driven by the UI in this particular choice of using GraphQL. Now, the other thing with GraphQL here is that we have a schema. And this is really similar to routes in a sense of it's what we expose, but it's a little bit different way of thinking about it, where in a similar way that we define our schema and our models, we have this layer in GraphQL to say, all right, our GraphQL layer exposes a message type and a user type and a query for all the messages. So what might working with this look like? Well, with GraphQL, everything is a post request, and our endpoint is GraphQL. But we need to actually send over a query here. So this is going to look like this. It's going to be a query, and a GraphQL query is actually a string, and it's really its own micro language that looks a lot like JSON. So this is kind of the outermost thing. And if we look over here at our query type, we see that we can query messages. So we can just type in messages here. And GraphQL, which is coming from the official GraphQL package, is pretty cool. The integration here is pretty light with Mirage, but basically we're going to get these helpful error messages. The field must have a selection of subfields, and so we can't just fetch all the messages and everything about them. We need to be more specific, and so we can do that like this. So let's say we want to query the IDs for the messages. I'll just zoom out so we have a little bit more room. And there we see the response from our GraphQL endpoint is just giving us basically the message ID fields from our message. And so you can see the response really kind of matches the query, and that's one of the big ideas behind GraphQL. Now, our messages also have, a text property, so we can say, let's also get the text. Maybe we just want the text. Maybe that's all we care about. And again, nothing about our server has changed at all. We're just able to query exactly what we want. Now, if we look at the type that we've defined here, it also has a user. And so we can get our relationships just by specifying them like this. And I think we'll get an error here where we need a subselection as well, because user is another type. So we'll do the same thing. And let's just grab the ID of each user. And so now we're getting all of our messages with the ID, but maybe we don't actually need the ID. Maybe we just need the name. And so just like that, we kind of have created this nice little payload. It's an array of messages, right? And it has the text of the message and the name of each user. So this is like really hyper optimized for whatever specific page we're rendering. Let's say we're rendering the conversation here. We literally only have the data that we need for it. Now, is this normalized or denormalized data? Well, we can see that there's definitely duplication here, so it's denormalized. So GraphQL is in some sense solving the same problem that JSON API is by giving the client more control about what it queries, but it takes a different approach and says, as far as normalization goes and denormalization goes, that's up to you. And you have the power to query something like this that's going to let you render exactly from this JSON payload what you need. But we're not going to help with basically normalizing the data and making sure that you keep things in sync. That's kind of a layer above GraphQL. There's libraries that, of course, help with this. But at the lower level, you can see it's very easy to produce denormalized data. So again, back to these trade-offs. Sometimes it actually is really nice to just get a payload like this and render it and not worry about the normalization or not need a notion of identity on the client. I mean, we're not even including IDs here, so there's really no notion of identity. We could have different users that are both named Sam, and we wouldn't be able to tell, which one is ID 1 and which one is ID 3. So this really takes that idea to the logical conclusion, and I just wanted to show off this, and you're welcome to play around with this kind of in your own time. Pause the video, play around with it, because really it's just another way to solve it. And obviously, GraphQL has become tremendously popular, so it's not something you should just ignore. You should understand the problems it solves and why certain companies and teams use it for certain problems. And this is just one aspect of it. There are other aspects of GraphQL, but I just thought it really fit nicely into this conversation right here in explaining how we can choose to expose our server resources to our clients. All right, let's go over to exercise 12. And we're going to circle back to a little bit more about domain modeling. So here we have the user and message model and the one-to-many relationship, just like before, but we also have a new model called channel. And down here we create 3 channels: general, video, and podcast. And if we look at our database here, we can see users and messages, and then channels is right here. So the question is, how might we associate users with channels? Well, in Slack, a user, Sam, can join many channels, right? So a user has many channels. I can be part of general and video. But what about a channel? A channel can also have many users, right? It doesn't make sense to just have a single key like user ID on here. We would need an array because both Sam and Ryan can join the general channel. So we need a has many on this side as well. So this is what's called a many-to-many relationship. And we can do this. If we come down here to exercise 12, just like you would expect. So a user has many channels, and a channel has many users. And now in our database, Mirage has added a channel ID's foreign key to our user side and a user ID's foreign key to our channel side. So let's come down here and give these channels some users. So users is an array of users. Let's say Sam and Ryan are both in the general channel. And then in video, users is just Sam. And then in podcast, users is Ryan. And now you can see Sam has two channel IDs, 1 and 2, which is general and video. And the general channel has two user IDs, 1 and 2. So again, just because we passed in the users to the channels, Mirage is keeping these foreign keys in sync. And so now if I wanted to say, well, let's get users 1 and include their channels because we want to look at those. Well, now we have all this data that we need, right? We've got the 2 pointers here and all of the data included. So we could write out the channels list for a user. Or if I was in a channel, let's get all the channels. Maybe we want to get channel 1 and we want to see all the users that are in this channel. We can just say include the users here. So this is a many-to-many relationship because the has many is on both sides of it for each model. And we can see, it works out really well here for exposing all this data, in whatever way we need. And again, just to see that Mirage will kind of preserve our referential integrity here. If we were to go ahead and, let's delete this. Let's say we have channels 3, which is the podcast channel. If we were to go ahead and delete that, I think right now, Ryan is part of channel 3. If we were to delete that from our system, there we go. This inverse relationship is updated, so Mirage is preserving the integrity of our data for us. But let's look at a common action that you might want to perform from the client to this data. So I'm just going to go ahead and refresh this. And right now, Ryan is in channels 1 and 3, right? General and podcast. So we can get /user/2, which is Ryan, and include his channels. There they are, 1 and 3. Now, what if we wanted to write in the UI a way for Ryan to leave channels? In Slack and Discord, you can join and leave channels. What would that look like as far as the request goes and the data that needs to go back and forth? Well, if we look at our users table here, what needs to happen is we need to either update the user Ryan here and remove 3 from the channel IDs, or update the channel and remove 2 from the user IDs here, right? That's kind of what needs to happen in the database layer. And so the way you can do this with JSON API is that we can grab this kind of snapshot of the Ryan user model here, and we can send a patch request to user 2, right? So this is how you update records using REST. So if we were to paste this, go ahead and close this out. This is basically, the current state of this user record. So if we were to just send this over, we see it doesn't change. And if I were to change the name to Ryan Toronto, send this over, we see that that updates. So, patch, the way patch or put works is that it overwrites kind of everything in your backend. So you need to know enough about the current user in order to update it. And so here we have the channel IDs here. And right now, Ryan belongs to channels 1 and 3. So let's say we wanted to remove him from the third channel, the podcast channel. Well, we can just remove that from the list of foreign keys here. This is really a foreign key in the language of JSON API. And so if we say Ryan's only channel is channel 1, and then we send that over, now the channel IDs update, and also our podcast channel is now empty. So that is what our client app would have to send over, in order to remove Ryan from a channel. But if you think about it, it's kind of a bummer to have to know all this information, right? Just because of the way patch works and REST works, you're really transferring the state of a resource, from client to server or from server to client. So the client has to know all the channels here that the user already belongs to just to remove one channel. So we have to know that Ryan is in channel 1 and channel 3 just to remove him from channel 3. And you can imagine in a big system, if we had a ton of keys here, just to remove, like if this was all these keys, right? And we needed to know them all just in order to remove him from one. I mean, that's not really a sustainable thing. That doesn't really make our lives easy as front-end developers. It would be much easier if we could just send a request that's focused on, we have user 2 here and we want to remove him from channel 3. That's all we need to know in order to make that action occur. And so, this feels like there's not really a good way to do this with how we've modeled this domain with these 3 tables and these relationships the way we have it. There's no combination of verb and noun here that makes that very easy. So what happens a lot of times you'll see teams do, and you'll reach for in situations like this, is to basically start making up new actions and verbs that your server exposes. So if you've ever worked on a problem like this and you say, I really just want an endpoint where I can just remove a user from a channel. So maybe I have a user/2 and I have like a remove channel action. And maybe I just send over something like, I don't know, channel ID 3, something like this, right? Who knows? We just get to make up stuff. And so, this feels like it makes my life so much easier, right? Because I've got my user 2, I just need to remove the channel. And now I don't need to know everything about the user just to do that. I can make this very simple request, and it seems a lot better, right? Other things that you might have run into with this, like maybe you need to subscribe a user to something. So you do something like user/1/subscribe, and you just say, all right, let's let the client app make this request, and then we'll maybe send off an email, something that doesn't really fit into the normal CRUD operations that we've been talking about here. Or maybe you have like a posts that you want to just publish. You want to click a button and publish a post that already exists, and you need to like send it out to some service and send an email or send a notification. So you just say, all right, what if we just had like a publish endpoint that we could just hit and trigger all these actions, right? So the problem with this approach is that you're basically going outside the boundaries here. You're going outside the lines that this entire architecture is based off of. And like we said at the beginning, you can do anything here because every time we make an app, we basically are writing a lot of this stuff from scratch. And so it's very easy to reach for this kind of thing because it seems like the simplest solution to the problem. But there's actually a better solution. And the solution here is to think, how could we model our domain in a way that would let us achieve what we're trying to achieve just using these verbs and resources and keeping our code super conventional? Up to this point, we've been able to use all these shorthands because we're really abiding by the principles of REST, and it's been very clean so far. We haven't had to use any escape hatches. So how might we do that here? And the way you do that is by creating a new resource that represents the relationship that you're trying to change. So what would that look like here? Well, Our user has many channels, and our channel has many users. What represents a user and a channel belonging to each other, right? Well, that would be a membership. A membership is the noun that reflects the notion of this relationship, right? So far, the relationships that we've described and defined kind of make sense on their own, but this many-to-many relationship is really significant enough in our domain and in our UI that it really deserves its own name. And so a lot of times when you run into these problems, you start thinking about this and you say, oh yeah, that's a membership. That actually makes a lot of sense, right? It makes sense to talk about a membership as a separate thing apart from the user and the channel. And you can imagine, like, maybe there's private memberships. Maybe certain people can belong to different channels based on authentication rules. So once you get to this point, giving this thing a name usually opens all sorts of possibilities for ways to improve the domain modeling and how you expose that data to the front end. So what would it look like if, instead of making this a many-to-many relationship here, we actually introduce an entirely new model just for this purpose? Well, let's go over to exercise 13. We'll see that we have our channel set up with our existing many-to-many relationship. And what we're going to do is just come over here to 13, and we're going to create a new model. And it's going to be called a membership. And what is a membership? It really joins a channel and a user. And so a membership is going to have a user. That's a single user, so it belongs to. And it's going to have a channel. That is a single channel, so it belongs to. And we'll go ahead and get rid of this many-to-many relationship that we had defined earlier. So now if we come and look at our data, user has no notion of channels and channel has no notion of users. Oh, it looks like we have some old data creation logic here. So down here, instead of updating our channels, passing in those models, we'll just get rid of that. So now our channels have no notion of users, users have no notion of channels, but membership is really going to be the record to store that relationship. So instead of updating, like we had before, the user's property on a channel, to create this relationship, well, now we can just call server.create membership. And let's go ahead and create a membership between a user of Sam and a channel of General. Again, our user still has no notion of channels in the database layer, same with channels and users, but a membership now exists between user 1 and channel 1. Let's create the other memberships, Ryan and General, Sam and Video, and Ryan and Podcast. And there they are. Okay, so you might be thinking, well, that's pretty cool. We have this separate thing here, but if I want to get my channels list, like the first thing that happens in Slack when I sign in is I see all my channels. Now when I go to user/1, there's Sam, but how can I possibly query for my channels? Because the only relationship that Sam has are these messages. Well, we can create a pointer to this relationship right here. We know a membership belongs to a user, so this is really another one-to-many relationship. So if we come to our user and say, you know what, the user actually has many memberships, right? And we know that because we know the membership points back to the user. And so kind of from the storage perspective right there, there's all that data. And again, this is really just boils down to another one-to-many relationship between users and memberships. And in the same way, a channel has many memberships, right? That's what we started this off saying, is that a channel doesn't just point to a single user, it has many. And now we're representing that relationship via memberships, so we can say a channel also has many memberships. Okay, and now when it comes to querying, let's go ahead and get Sam. And if we look at our schema over here, Sam has messages, so we can include his messages if we wanted to. But if we just wanted to get his channels, how would we do that? Well, we can get the memberships, and there are the memberships, which is not really helpful in terms of showing us the channel names. But with JSON API, we can actually traverse this graph using dot syntax, and every membership has a channel. So now when we hit enter, we get the membership. The membership points to a channel, and there we go. Sam belongs to general and video, just with one query, just by traversing our model like this. So that's pretty cool, but earlier we were able to get all of Sam's channels. The hard part was updating them. So let's say that we wanted to remove Sam from the general channel, right? We see down here, Sam is in both the general channel and the video channel. Well, now what we're going to be able to do is get a hold of the membership that represents this. So general channel is ID 1, so channel ID 1, and Sam is user ID 1. So this first record, this first membership row right here, represents Sam belonging to general. So how do we remove Sam from a channel? That's easy. We just delete memberships 1. Oh, we forgot to expose the resource down here, so let's come down to routes, resource membership. And this is important, right? Membership is a first-class concept in our system that we're now exposing to the outside world. And again, there's that membership, Sam belonging to general. Go ahead and send a delete request to /memberships/1. We do that. And so if we were to requery for users 1, which is Sam, and include all of his memberships.channel, here we go. We just see video. And so this hopefully really shows off the power to you of getting the domain model right, because this problem that seemed so intractable before, how can we stay inside of these normal CRUD operations without adding something like, you know, a /add or remove channel action to our API, which we know feels bad, but we don't know how else to do it? Just by naming a new resource and getting the modeling right between these foreign keys and relationships in a way that makes sense for our domain means that now we can create relationships and delete them in a very first-class way, in a way that's going to feel right, whether we're using Ember Data and calling store.createRecord and find record, all of these kinds of things. It just makes this whole graph of data that exists in our database much easier to query and modify from our client. And so, you know, just like before we were talking, it can be tempting to say, you know, we want like a subscribe action, but you know, subscribe is not a verb, so we have this same problem. If you find yourself reaching for this, you probably need a new relationship. So what would this relationship be? Well, maybe it would be a subscription. So if you have a subscription that points to a user, now you can create it, and that would be the verb, that would be the post verb, a normal CRUD operation on this new resource. And same with the posts/1/publish. What would that be? Well, that would actually be a publication. So now if your app needs to publish a post, all you need to do is create a publication, right? So this is an extremely powerful concept that really kind of sheds light on this whole question of domain modeling and how important it is to get your domain model right. If you look at the README, you'll see at the bottom here, one of these talks is from DHH, and it's called Resources on Rails. And it really does a good job of making this point. So I highly encourage you to check this one out. All right, let's look at the last exercise, which is just going to give you some practice with this concept. Let's say that we want users to be able to be friends with each other. So if we come over and look at 14 here, we're back to just users and messages here. And let's come over to our code and look at 14. And one thing you need to know for this exercise is that so far we've just used these has many and belongs to kind of by themselves. But let's say we wanted to add a friends relationship to this user model. And a user can have many friends. Hopefully you have more than one friend. So this is probably going to be a has many, right? Well, by default, this is going to look for a model called friend. We don't have a model called friend, and we don't necessarily want to add one, right? Because a friend is just a person, and we already have this user model. So in Mirage, you can say you know, this friends relationship is actually a user model just like this. So far, we haven't had to do that, but here's how you do it. And so we can create a many relationship right here. Come and look at our database. There's our friend IDs. Let's come create some more people. We'll create Yehuda and Tom. And then let's go ahead and say Sam update friends Yehuda. Oh, they're all my friends. Ryan, Yehuda, and Tom. Right? And so now we have a many relationship here between a user and their friends. So that's how you would create a relationship that has a name that's different from the actual model name of the underlying model. So the exercise here, that was just what I just did is a very simple kind of has many version of this. But you know, we just saw some problems with has manys when it comes time to update them from the client. It's much easier to work with this new record that represents the relationship, which I forgot to mention, but you'll sometimes hear it's called the join record. And so up here we just went from a many to many with this join record by making a membership, and now we have a many to many without a join record, and the goal is for you to make a join record and be able to do the same kinds of things that we were doing to memberships. So if I became your friend, what would that look like from the perspective of the query that the client had to make? Or if someone unfriended you, what would that look like when you have that new join record? So this one's a little bit tougher. It's the last one, but I encourage you to pause the video, give it a shot, and make sure you kind of, you know, it can be a little confusing when you first learn this stuff, but it's really important to give yourself enough time to try to think about it, because when you identify that new resource, it makes a lot of things click. So pause the video now and give this a shot. All right, let's see how we might approach this problem. So again, we have the friend IDs here with the many to many. And so if I got user/1 include my friends, well, there they are. But if I wanted, you know, if Yehuda wasn't my friend anymore, we'd have to do that same rigmarole that we did before. I'd have to copy all this, and we'd have to send a post request with all these IDs except for ID 3, right? And so instead, we want to create that new resource that represents the relationship. Basically, whenever you start performing CRUD operations on relationships, it's sometimes a really good sign that you need a new resource, right? And so what might this look like? Well, instead of being a friends here, what if we had a friendship? And a friendship is a relationship from someone, so it belongs to a user, and to someone else, right? And you know, there's a lot of ways to model data when it comes to this stuff. You know, we've really been covering the core fundamentals, the basics. Domain modeling is a really complex topic, and really experienced people will disagree about how best to model something for their project. But this is just one approach you could take. And so now we have a friendship right here, and a user has many friendships. And this way we can get a user and all their friendships, right? And if we come back and look at the app, we're actually going to see a white screen. If we look at the console, we'll see an error. It says, Mirage, you're trying to create a user model and you passed in this. Oh, it's because we need to update our seeding logic here. So this is no longer valid. Let's just delete that. And so now we have a friendships table. So instead of doing this where we update Sam's friends, let's go ahead and create, it's kind of funny language. Let's go ahead and create a friendship from Sam to Ryan. I think he's still my friend. So we'll do that. And now we're going to hit another error. And this is kind of just starting to get into how some of this gets complex, right? But it says, Mirage says the friendship model has multiple possible inverse associations for the user.friendships association. And so what that means is that, you know, Mirage is trying to keep these in sync, and it says, hey, friendships right here has many, And over here, we've got 2 foreign keys that point back to my user. So I need to know which one of these I need to track, which one I need to keep in sync with. So we can tell it by doing inverse is the from case. And so now Mirage will keep the friendship ID's key on the user in sync with the from ID key on the actual friendship. And so now we should be able to close that console and look at this again. And so now Sam has the friendship IDs right there. And over in friendships, we see a from ID and a to ID right there. So we can go ahead and create all the friendships from Sam to Yehuda, Sam to Tom. I guess I'm just getting lonely because it's coronavirus, you know? And there we go. We see all of Sam's friendships. So now our client would be able to say, let's go ahead and query Sam and include all of his friendships. And each friendship, we also want to include the to. And so now we can look at what's included right here. There are the friendships, and there are the friends, the actual users. And if Yehuda didn't want to be my friend anymore, how do we do that? Well, Yehuda is 3, I'm 1. Find that friendship, 1 to 3. So this is friendship 2. And of course, you don't have to look all these keys up. Presumably your UI would be able to present this in a much simpler way. But just again, to make sure you really can just feel comfortable understanding how this data is stored at the database level. Now to remove that friendship, all we got to do is send a delete request to friendships/2. And of course, we need to expose this friendship. So friendship between us, friendships 2, delete, send that off, 204, that one's gone. And over in users, that's been updated as well. So again, just an example of how powerful this idea is of coming up with new nouns that really represent the relationships in your system. It's really an expansive idea that can really clean up your code, keep your server code really clean, but also keep your client-side data fetching and data manipulation code clean, because look, we're just sending a delete request to a resource. That's all there is to it. So no need to make all these new verbs. And this is really the trick to staying in the lines kind of as long as you can. So hopefully that was a good tour of the fundamentals of modeling your data. Hopefully you appreciate and understand a little bit more about how important it is to get this right. And I'm sure, you know, if you've worked on an SPA, like a big Ember app that is data driven, you understand at an intuitive level, right, how much the data modeling can affect your productivity and your team's ability to really think clearly about all this stuff. So the question is, you know, how do you get better at this? At choosing good domain models, at encoding the logic and facts about your system into the model in such a way that makes it hard for folks to kind of screw it up when they're either fetching or manipulating data. Really, the best thing to do is practice. And over time, you will develop an intuition. You'll say, you know what? We don't need a subscribe action. There's actually a subscription there. Or really, oh, this is really a new relationship that should be pulled out. And what's the best name for this? How can we talk about this in a first-class way? You know, a lot of times, just the way people talk, maybe not even non-technical people at your company, maybe they talk about subscriptions and memberships, and then you think, oh, okay, that actually would make sense as a table. And so far, that notion has just been embedded deep in our database, in our server resources. We haven't really identified it as cleanly, but this is something that people think about in a first-class way. So let's pull it out, give it its own name, figure out the best way to relate it to other models in our system, and it can have a pretty dramatic effect on how clear your code is and how easy it is to understand and manipulate the data in your system. So hopefully you learned a thing or two there. If you have any questions, we're going to be in the Discord channel. You can also reach us on email. Really appreciate your time, and thanks for watching.